Welcome everyone to the EdmontonPy Meetup. If you haven't been here before, this is a Python user group. You can find information on EdmontonPy.com, on Twitter at EdmontonPy, and we're also on the Dev Edmonton Slack and the Meetup EdmontonPy channel. So if you want to chat and say hello outside of Meetup time. Today's sponsor is Helm. So thank you so much for Helm for sponsoring the pizza. If you get a chance, say thank you on social media. It's really important, and it's really to be kind of thankful that we have companies that want to engage with the community. So definitely always pass that along when you run into those folks. And we always want to thank Startup Edmonton for this wonderful space today, which we are very spoiled to have with all this awesome technology. We don't have to run around and find spaces every time. Just what we've want to always mention the Pac-Man rule. So, when you're standing in a group of people, always leave room for one person to join your group, aka stand like Pac-Man, and that makes it a lot easier for new people or people who may not be, as outgoing as other folks to be able to kind of join the conversations really easily. And it's a really nice and easy way to welcome anyone, to make everyone feel welcome. I'm still out of breath from running over here from the parking. Just gonna run through a couple of events that are happening. PyCon Canada is coming up this weekend. There's still a chance you could go. There's still a couple days if you want to go. It's out in Toronto. It's gonna be super fun. PyCascades is coming up in Portland on February 8th to 9th. I believe their grant application, if you require a financial grant, they do have financial grants, and you have to apply by the 15th, so you have a couple days, 2 days. The PyCon US, the next one is going to be in April 15th to 23rd in Pittsburgh. So keep those in mind. Just a couple of news pieces. Python 3.0 is the latest stable that's available. If you want to do some Python work, the official pip there's going to be some official work to improve pip and the dependencies. They've officially got some, I think it was $400,000 grant to basically hire 2 full-time, or however they split out the money, to improve that. So we get benefits, but hey, if you're looking for some contract work, that's a really great project to work on as well. It's officially, I guess, according to the stats on GitHub, that Python is now the second most popular language. It just jumped over Java. And the other official news, I guess, is that we are now going to be in a regular 12-month release cycle for Python releases, which is going to be really good to kind of prepare for everybody in terms of knowing exactly what date's going to happen, and to be able to adjust all the packages. The other package maintainers can adjust easily as well. Some articles that I came across that I think are worth sharing. There was a really great video. This is actually a 6.5-hour video course by the Free Code Camp, I think. 6.5 hours by Learn Python by Building 5 Games, full-on course from start to finish. So if you're learning Python, and that's a great course to be, so really good quality. There was an interesting article about web frameworks, but the really new shiny ones, the ones that are mostly async, like things like Quanta and things like that. And really, I only heard of like 2. So the other 9, if you want to know what they are, definitely check out that article. I'll put a link on these slides onto the channel, so if you want to click on the link. There was a little short tutorial about how to set up some continuous integration with GitHub Actions, Poetry Black, and PyTest. So it's all running it's blackifying your code, and it's running the tests for you in GitHub. Super sweet and easy. The Python datetime tutorial to manipulate times, dates, and time spans. So it's a really nice and thorough tutorial. So if dates are your thing, and it probably is for most of us, because it's always been tricky, that's a really nice thorough tutorial in there. There was a little short article covering less known bits of the Python standard library. So things like pprint, for example, that some people know, but not many. So there's a couple little gems in there. If you work with Django, there's a Django admin cookbook that just got updated. So all the way to, I'm sure it was Django 2.0. I don't know how far up on that was. But if you have to customize Django, you've had to customize Django admin. There's a lot of recipes in there in terms of what the best way to do that is. A great in-depth article about the cleaning up currency data with pandas if you're doing more on the data science side of things. Another one, this one is pretty recent, so there's definitely a lot of kind of articles in terms of Dockerizing. I try to highlight ones that are more recent because that stuff changes pretty quickly in that. But if you want to just have like a more of a high-level overview of just like, hey, let's set up like a mini Flask app with Postgres, Unicorn, and Nginx up and running in a Dockerized container. Check that article out. And this is really interesting too, is creating a keylogger for Linux using Python, so kind of Python more on the system side of things. I'm really fond of these type of tutorials because it's not a lot of code, but it's very kind of, it gets you with a minimum amount of code something up and running, and you really got to get an overview of the foundations of some of the pieces, particularly on the system side of things. So it's a really good learning material. A tip, Python tip that I copied and pasted from this link right here, where there's actually like probably 20, 30 other tips that you can take a look. But I think as Python beginners, this has been probably most people that get into Python for sure, where you have a function that's defined, and as a parameter, you set a default value of an empty list. And what ends up happening is every time you run that function and kind of append a new value to what you're thinking is an empty list, it's not actually an empty list. It keeps adding to this one that I recreated, and that's because it's mutable. So what you actually want to do is make sure to set it to none and then initialize the empty list within the function itself. And then you will have what you intend to have. Definitely a nugget, I guess. I'm sure, who's run into this error? I know I have. So it's super, super common when you're learning Python as a beginner. So keep that in mind and learn from the bugs. Today's talk is how Python saved my basement. So I'm super curious about this. I'm super excited. And then Stephen Luman's going to talk about making a basic neural network model using 6 lines of code. Who's Stephen? Excellent. Awesome. So yeah, we'll have you on after the pizza. I'm super excited. The next meetup is on December 9th. So no rescheduling them. So we've had 2 reschedules in a row. A bit of messiness going there, but we're good to go. December 9th. Do we have talks? Does anybody want to talk in December? I'm not sure how up to date our schedule is, but if you have a talk in mind, if you'd like to do a 10, 20, 30-minute talk, come speak to me, Aaron, and Andrew over here and let us know. That'd be great. And next up, we'll just hand it over to Dennis to talk about Python and the basement.
A word of warning, mine is not 6 lines of code, so. Okay, my name is Dennis Miller, and as you can see, my presentation is called How Python Saved My Basement. So it's a little bit of a clickbaity title, but you'll see what caused that. But to do that, we have to go back in time. We're going to go back 6 years, and we're going to set the scene. To that. That basement is my basement. And on Friday, April 19th, in the morning, I drove down to Calgary. And in the early afternoon, I got a somewhat panicked phone call saying there's water in the basement. So I had my quite reasonable response was that, plus a few other words that my mother never taught me. And what turned out was our sump pump had failed. So it was running, but there was no water going out. And for those who don't know, a sump pump is in the basement of a house. and it collects the water from your weeping tile and any groundwater and then pumps it out. So that's been fairly common in Edmonton, I don't know, 20 years or more, probably 30 years. But older houses didn't do that, but newer ones do. Now we also get some seepage from the ground because we've got a fairly high water table. We're near the creek, so we ended up with the hole in the floor overflowing. And the carpet got wet, the bottom of the furniture got wet, the bottom of the wall got wet, and it ended up being about $7,000 of repairs. Luckily, most was under insurance. So this is how a sump pump works. You can see that there's a hole in the floor of your basement, and there's a pipe coming in from your weeping tile, which is basically just around your foundation. Lets the water come down, dribble into your sump, which is the hole. When it gets to a certain level, the pump kicks in, pumps it out through a pipe out onto your lawn. And the pump had failed, so that hole filled up, and that's basically what happened. And this is the aftermath. The restoration company came in, tore up the carpet, took out the soaking wet foam underlay. There's fans under those lumps there. That's what that's all about. Trying to dry out the carpet, dry out the concrete. The sump is the area where that thing is laying against the wall. That's the lid for the sump. There's the set of drawers beside it, and normally I've built a cabinet around there, a fake cabinet, which is just an outer shell, just to cover up the lid. And from another angle, you can see the lid a bit better, and that's the insides. So you can see the pump, you can see the pipe going out the top. The larger pipe down towards the bottom, it's a little bit dark to see there, but it's that's where the weeping tile entrance is, and the water comes in there. So I wanted to be able to have some warning. I wanted, because this pump runs 24/7 sort of thing, they do wear out and you do have to replace them. So I wanted to be protected against when it fails again. So I bought a water alarm. Cheap one, 75 bucks. It's got a simple sensor, which is just 2 wires in a little holder that you put down in the sump. And if they get wet, shorts out, the alarm goes off, and it was really loud. It's well over 120 dB. You had to wear ear protection to go into the room where it was. It did have a nice feature that it would phone a program number, so you could get, if you're out, it could phone you. Problem was, it was kind of an epic fail. We got multiple false alarms. I have no idea why. I don't know if it was just humidity was enough to trigger it or what. And of course, it always happened in the middle of the night. And I'm sorry, I'm getting too damn old to get a 120 dB thing screaming into my ear in the middle of the night when I'm asleep. The problem is, with a false alarm, you don't know it's false until you go look at the sump. And in my case, I have to take the top off, I have to take the fake cabinet away, I have to open up the lid, then I know whether there's a problem or not. So that kind of led me towards the things that I wanted to see in the alarm and in the monitor. So I wanted a better sensor. Obviously, the 2-wire sensor is not reliable enough. So I thought it was thinking of different ways, various mechanical sensors and things of that nature, but it had to be reliable, and I didn't like mechanical sensors. I also would like to be able to actually determine the water level, not just whether it's got a problem. I want to know how high it is. So I'm an electrical engineer by training, so I was looking at using an Arduino or maybe a Raspberry Pi. I don't know, are people familiar with Raspberry Pi? Fairly, okay. So, like any good developer, I don't want to do it myself if I don't have to. So I went out looking, and I found an application called raspi-sump that someone else had already done. Took a look at it. It was pretty good. It uses ultrasonic sensors, which are very simple and very easy to get. You can get them in town here for $5 to $7. It uses the Raspberry Pi. It's running Python scripts, and the Python scripts look after all the sensing, the monitoring, logging all the information, sending out alarms. It sends out SMS texts and email if you want. It also has a web server capability, so it will show you a graph of what's happening and where it is right now. So the two URLs down at the end, at the bottom there are the sort of the main page for it and his GitHub repository. So it basically had everything I wanted. I just had to do a few modifications, so that was pretty good from my point of view. So basically the hardware, ultrasonic sensor connected to the Raspberry Pi, a little bit of power, and it's got a Wi-Fi. Now, for those who aren't familiar with the Raspberry Pi, it has some pins on the upper left corner there. They're I/O pins, GPIO, general purpose input-output pins. So you can programmably control them, turn them on and off, or you can monitor them to see whether they've been turned on or off, that sort of thing. So that gives you the ability to control the ultrasonic sensor and talk to it. That's what they look like. I brought show and tell here. So there's a Raspberry Pi and a broken sensor. If you look at the sensors, there's different types of sensors. Ones with four leads or 3 leads. The one I ended up using had 3 leads, and we'll get into what that means. But the thing to remember is the Raspberry Pi is a full-fledged Linux computer. Now this is the one I use in the actual monitor is a Raspberry Pi, now called Raspberry Pi 1. We're up to model 4 now, but it was one of the originals. I bought it the day after they went on sale in 2012, I think. So it's not a high-powered, that particular one is not a high-powered one. The Raspberry Pi 4 is pretty good. But it's quite capable of running the programs, tweaking the sensors, logging everything, doing the web server all at the same time. It's not a big deal. So that's how it's mounted. So you can see the thing with the fake cabinet. The door section of that is fake. I've just got it on the wall. Cables go down into the sump. And the sensor is mounted on that board going across on the bottom side pointed at the water. And that's just a close-up of it. So how does ultrasonic sensing work? Basically, you'll notice as that gets around, there are 2 transducers on there, and basically it just sends a chirp out, reflects off the water or whatever surface it hits, and bounces back. And then you can determine that distance just with a simple calculation based on the time it takes that pulse to come back. It's fairly straightforward. I found that the sump was not a highly conducive environment for good performance. You get a number of things going on. You've got a pump in there, you've got pipes in there, you've got wires in there, you've got water in there. When there's anything coming in through the pipe, it drips, and now you've got ripples on the surface. So there's a tendency to not get clean data. So this is one of the differences between getting something off a database that it's got the guy's name and his phone number and all that data is clean. This is not. So you have to clean it before you can use it. So how this works. The trigger lead on the top there, you have to take that lead to a high potential for at least 10 microseconds. Then it cuts off. When it cuts off, the sensor starts its pulses. So you're seeing a chain there. I think it's 8 pulses that it sends out to do some averaging on the times and things like that. When it finishes its pulses, it then raises the signal lead to be high, and the length of time that it's high is proportional to the distance. So it varies there from about 0.15 milliseconds to 38 milliseconds, depending on distances. Now, this is shown as two separate leads. The one I've got has one lead. So not only do you have to do this, you have to do it in sequence, and you have to switch it around at the same time so that you actually end up having it acting as a trigger lead to begin with and then as a signal lead. So that's the hardware. The software, there are basically three streams here. There, on the left-hand side, there's a cron job that runs, I've got it set to run every 5 minutes, and it runs a module called raspi-sump monitor. Basically, all that does is to see, is it running? So it does a shell command, the psaux, to find all the processes, looks for the raspi-sump.py process. If it's there, life is good. If it isn't there, it starts it. And if it's there more than once, it kills them and restarts it again. So that keeps the thing going. Even if you've got a power outage or whatever, it'll come back. The stream in the middle is kind of the core. There's a starting routine, which is pretty simple. Basically, all it does is loop. And it loops the reading module, and the reading module is in control of the sensor module. So it tells the sensor to take a reading, and it gets the information back, and so on. That's where you do some cleaning of the data so that you end up with reasonably clean data, usable data. That data is then put down on the bottom box there into some data files, and there are also log files so that if there are any exceptions, if there are any problems with the sensor, any of those sorts of things, they go in the log files. The stream on the right-hand side, another cron job. I do that on a 10-minute cycle. And what that does is create the web information. So the first one, the raspi-sump web chart and web chart modules trigger off the development of the web chart. The today chart module physically creates it based on the data that it gets out of the data files. And data files are just comma separated variable text files. Pretty simple. Now those use matplotlib and NumPy to do a big load, and the matplotlib to do the actual chart. And it actually creates two charts. It creates one called Today, which is what is displayed on the web server. But I also have it saving one on a share with Dropbox. So then I can go outside the house and see that chart. The reason I did that is I don't know web stuff very well. So exposing this to the internet was kind of stupid on my part, because I would probably expose the entire home network. So using Dropbox was a convenient way of doing it. The problem was Dropbox doesn't have a client for Raspberry Pi. At least they didn't then. They might have one now. So what it does is I've got it shared with another Linux machine that I run all the time. I use it kind of as a house server. And it has a Dropbox link. So this thing just saves it into that machine's Dropbox folder. And then it goes out to Dropbox. The Raspberry Pi is running a light TPD web server, which I had never heard of until I got onto this. Basically, it's a lightweight, fast web server for hardware that doesn't have a lot of capability. So it's pretty simple, but it does the job. So what we'll do is look at some code. Now, is that big enough? Want it bigger? How's that? Readable? Okay. So what we'll do on the raspi-sump monitor, let's do this full screen. So I'm going to start with the left-hand side of that block diagram that you saw. This is the monitor. It can't get much simpler than this. You've got a process ID, and you call the check ID to see if that process exists. So the check PID, it creates some commands here, and basically all it's doing is asking what all the processes are and doing a search to try and find the raspi-sump.py process. And here, it checks the number of processes, and if there's none, it does a restart. If there's one, you just bail because that's good. And otherwise, there must be more than one, so it does a kill and restart. So if for some reason you created 2 instances of it, it'll kill both of them and start a new one. So the restart and kill process functions are here. So again, they just create shell scripts or shell commands, issue them, and depart. So that's the monitor that just keeps going every 5 minutes. And it's trying to see if this process is running. So this process, basically, it imports another one called reading. If you remember, that was the next box down. It sets some configs. So there's a config file that you can set things like the depth of the sump, at what level do you want the water to alarm at, temperature, because there's actually a temperature correction because the speed of sound varies with temperature. There's no altitude one, so I don't know how accurate it is if you're in a higher location than a lower location. How often you're going to read it, all these sorts of things are all in the config file. You can set them to what you want. This brings them out and sets things up. Now you'll notice in various places it got previous value. This is where I start keeping track of what the thing was before so that I can compare it with a current reading and see, do they make sense? Because normally the water level does not change a great deal between measurements. The only time, pardon me, the only time it does is when the pump runs. So then it goes from full to empty. That takes about 50 seconds. So that one is legitimate. Other ones of more than fractions of an inch are not legitimate. So that's how we keep track of it with the previous value compared to the current value. This can be run, and I should mention, all of this is not my code. This is Mr. O'Day's code. All I did, I modified it a little bit. The sensor module I had to do myself based on his because he used a 4-lead and I was using a 3-lead sensor. And I made a few minor changes to make it work the way I wanted to work. But this is set up so that you can run it, for example, on a cron job every 5 minutes or every 10 minutes or whatever. If you want to do it that way, you set the reading interval to 0, and then your cron job triggers everything off. In my case, I've got an interval, so I'm down here. I set up a reading.waterReading call to the reading module and basically say, I want a new one. This is the old one, I want the new one. And then this thing sleeps for the reading interval. In my case, it's set to 30 seconds. So every 30 seconds, it takes another reading. And basically, that works out to about 1 million measurements a year. And this thing's been going for, I think it was 2015 that I started it up. So 4 million or so measurements sitting there. I've kept them all. But they're set up in files, so you can delete the files if you don't want to keep them. So the key thing here is this reading.waterRead, water reading, sorry, which is going to control the the actual creation of a value, which is the depth of the water, or the depth of the water. So we're now in the reading.py module. It imports the sensor module, the logging, and the alert module because I want to alert if something goes wrong. And basically we pull out all the configs. These are a bunch of the configs that you can do with the temperature and which pin you're using. Is it metric or imperial? The spike threshold at the end there is just how much I'm going to allow the change to be between readings. So here's the key function. It is what controls doing the sensor. So we've got our various things to do the calculation, how many decimal places we want to round it to, what the temperature unit, all that sort of stuff is. Here, we ask the sensor module to create a measurement object, pass it in the various things it needs to know, and then here we ask it, what is the distance? And that method of that class will tell me what the raw distance is. Just some little unit changes there depending on what your settings are. And we get into some of the checks here, determining what the amount of movement has been compared to the previous one and whether we should throw this measurement away or not. And that's basically what it does, is it figures we've got a bad measurement, so we'll throw it away. And basically down here, the generate log is a method that actually triggers the saving of the value in the CSV file. Generate log is the actual method, and it just does a log of the reading with the water depth in it. And basically that's just a timestamp and a value of the depth. Now if we've got a problem, it'll trigger the generate alert. And you can turn them off. So there's a flag there that you don't want alerts if you're doing testing or whatever. So it looks at, okay, what's the date and time? And ultimately will return the last alert because I have a throttle on it, so it doesn't alert with every measurement. You can put in an interval and say, just tell me every 1 minute or every 5 minutes or every 10 minutes. Otherwise, you get alert after alert after alert after alert. So it just looks at the water depth. Is it beyond the threshold? If it is, it uses the SMTP library out of the standard library, and in the alerts module, it triggers the sending of all the messages. So that's the call there. If it doesn't get through, then we log it that, hey, we didn't send the alerts because the SMTP server isn't working. You better do something about it. And we set what the last alert is to the current time. So that's basically it for reading. The sensor module, it has a class. Again, sets up a bunch of settings for which pin it's going to go on and so on. The raw distance method is the one where it finds out what the distance is. So that section there is determining based on what unit system you're using, what the calculation is for the speed of sound, basically, which is calculated here. Now here's where it gets a bit different. There's a module with the Raspberry Pi or available for the Raspberry Pi that accesses the GPIO pins. It's actually written in C at the low level. And you can call various methods on it that control those pins. So the first one that's of interest here is we set the mode of, there's at least 2 different ways of counting pins, of course. So this tells it which way you're doing it. We set up a loop here. We tell it to set up the signal pin as a GPIO output pin. So this is now going to act as that trigger, that first red line that you saw. It sets that to low because it has to be at a low level to begin with. We sleep for a bit. We turn it high for 10 microseconds. Then we set it low again. Then we set it to be an input. So we set it to be an output. We've timed a 10 microsecond pulse. We've turned it now to an input, and it's going to start listening on that same wire. So that's how we get around the fact that it's one wire doing 2 different things in 2 different directions. And that's just a flag there that I want to be able to know whether it actually started and ended, if it did or did not. There's a timeout class, which is a context manager. So basically what that does is look after the situation where I sent it a pulse, but it didn't answer me. So it'll time out. I've got it set at 1 second. So I don't want it to hang there if it missed, because you got to remember, this is real time. Linux is not real time. You're running a Python script at whatever speed it might happen to be. So you have to be aware of the possibilities that you're not going to get any answer. So if you didn't have this, it would sit there forever and never measure anything. So what it does is basically wait the 1 second. If we haven't had a response, then it bails. So this one is no response to the start, because we said to start, do we see the start of the reply? And do we see the end of the reply? Did it lock up and stay high the whole time? Because it's when it goes low that you know what the time is. So just some checks here on whether it worked or not. Cleans up. And you get situations here where we append the distance to a list. Because I've got this in a loop, I do 5, so it's sending out 8 pulses. I'm doing that 5 times. Again, because real life is ugly. It's dirty data that you'll get. So I do it 5 times for some sort of hopefully good result. Sort that list and take the median of it, because hopefully the outliers are out of my way. And that works reasonably well. There are times when it doesn't, but you go with the flow. These ones are basically just calculations based on the unit system, the actual calculation of the distance, and so on, both in metric and imperial. This is the timeout context manager. I won't go through that in any kind of detail. Alerts, configs again. Set up the SMTP alerts. It passes in the water depth because I want to know how bad this thing is. Because I'm getting alert, I want to know, is it ready to overflow the pipe, or is it just a little above the threshold? So it builds a body here saying from who it was from, who it's to, what the subject is, and then some information on what the value is. And then creates an SMTP server. And it allows for, if you've got password protection, you can do that. And then you issue a send mail. Now you can send it a list of addresses, so it can send to more than one person. So I've got it set up so it sends it to my phone, it sends it to my email, it sends it to my daughter's phone, my daughter's email, just in case. One thing I found out is, at least with Rogers and TELUS, you can send an email to a specifically formatted address, and it'll come up as a text message on your phone, which is kind of handy. So that's how the alerts work. So we've got it coming down, doing the measurements, saving the measurements, alerting if need be. If no alert, it just keeps on going, and it runs forever. However, the web charts, I want to be able to actually find out what the results are without having to read a bunch of numbers. So this sets up a few variables that we need to know. It calls the web chart module to create folders, create the chart, and copy the chart. So creating the chart, or creating the folders, I should say, is because it splits it up by year and month. Year, month, and day, actually. So you don't get one file with 16 gig of data in it. You get a whole series of files, so you can get rid of the old ones if you want to. The create chart ends up calling the WebPy chart and the today chart to physically create a matplotlib chart, which is then saved as an image to be served by the web server. And this copy saves that image also as a historical image for that day. So these calls to web chart go out here, does the create folders, checks whether they exist. If they don't exist, create them. And basically what happens is automatically when the time changes over, the midnight point, those values change. So it says, oh, I don't have them. So it creates them automatically. And then every time it goes through, it keeps checking. The create chart we have the directory and the file name. And here we create a chart.graph. Now, chart in this case is the matplotlib library. And doing that will trigger the today chart. So it's raspi-sump today chart as chart. So that's going to trigger off the whole creation through matplotlib. And then this just copies it into the archive section of the file. So the today chart, we've got, this is where we get into the nitty-gritty of the matplotlib and its setup. And this is actually where I did make a change in this. I split, it had one large graph, I split it into two subgraphs. So basically, I blocked it out using noon, so I've got a morning chart and an afternoon chart on one page. And this is just basic matplotlib commands to create the chart based on the CSV file and then save it. And the file name here is today.png or todaychart.png, I can't remember which. And here's where I had another change because the path there, the home pi sump share today.png, that is actually on the other machine, and that is the Dropbox folder for that other machine. So I try to save it there. I have to catch that exception because if the other machine gets turned off or something when it's trying to do it, I don't want it to error out. So it logs it and then re-raises the error. These two methods, or this method is just to create the subgraphs with the appropriate titles and tick marks and all that kind of good stuff. Nothing particularly special there. So that's basically the code. Now you're probably wondering, how does this relate back to the clickbait title? Because it's just monitor stuff. So to Oh, first of all, that's the web output. So you've got the morning, the afternoon, you can see it gradually pulls up and then pump runs and it's emptied out. And then it gradually comes up again. Now that can actually happen fairly quickly. When it's rainy or wet or whatever, it'll cycle quite often. But this time of year, this was September. It's not too bad. And then towards the middle of the winter, it drags out its days before it'll run. I didn't talk much about it, but there's also an HTML file and a CSS file to do the headers and the logo there. The buttons at the bottom allow me to cycle back through those archive files so I can look at the older ones and compare them to the current one. So, the clickbait title. Basically, we have to go back in time again to last year about this time. Same place, 3:04 a.m. All of these things happen in the middle of the night. I don't know why. It must be a universal rule. So November 6th of last year was actually the first really cold night of the winter. So at 3:04 a.m., I started getting this. My phone starts buzzing on the night table. I look at it. I see that we've got a sump pump alert. This tells me the depth of it, so I know I've got a problem. So we get the same sort of response, again with more words that my mother never taught me. That was the condition. So you can see about 1 a.m., you can see there's a bit of kink in the chart there. Basically, that's when the pump started. Tried to pump, it wasn't pumping. And it continued to get higher and higher until it hit the red line, which is 10 inches, which is my critical water level. So at that point, it started sending those text messages. So charge downstairs, take the lid off, take the case away, flip up the lid of the sump pump. Yep, water's up there. I turned off a Raspberry Pi at that point, powered it down so I could just move things around and not worry about it. When I powered it back up again is where you get that zig back. And the reason for that is that the Raspberry Pi does not have a real-time clock. It gets it from the network. So when it restarted, it didn't know what time it was. So it wasn't until it did a query out the network that it figured, oh yeah, it's over here. It's almost 4 o'clock in the morning now. And then it started redoing the measurement thing, started cycling again. The chart started getting built again, all automatically. So why did this happen? Well, you saw the diagram before where you had the pipe going out. Normally during the summer, I've got a pipe running out to the street to dump it on the street rather than dumping it on the lawn, because the lawn tends to get a bit soggy there. But in the winter, that pipe will freeze. So what I do is I have a short pipe that goes into a piece of downspout, 14-foot piece of downspout that runs out towards the front of the yard and dumps it out on the front of the yard. Problem was, when I put it in, I wasn't really paying much attention to it. That's the hose, that's going into the downspout. When I put it in, I had actually kind of bent it so it dipped down a little bit. So there was a low spot that never drained. So that built up and created a solid ice plug in that pipe. So I had to get that off, and of course it's cold. Got that off, took it inside, put it in hot water, got it running again, took it back out and screwed it back on, restarted the pump, restarted the Raspberry Pi, and that's where you see the restart here. That took me almost an hour to do all that stuff. Now, would that have flooded the basement? Theoretically, I don't know. It was still going up at the time I stopped it. So I have to assume, yes, it would have flooded it. So I can say about $75 for the Raspberry Pi was about $50. Then a few accessories like the Wi-Fi plug and the sensor, there was something else in there. So call it 75 bucks. I bought one for 75 bucks. It didn't work. Made one for 75 bucks that worked and probably saved me $7,000. So that's it. Anybody got questions?
Does that sensor need calibrated when you first put it in?
In theory, no. I actually measured it, and it was pretty close, but I think I adjusted the temperature a little bit to cause it to come out to what the ruler said was the actual depth. You're getting back to, you've got a pulse that you're measuring in a non-real-time operating system. If you did this one with an Arduino, it would be very accurate. But with Raspberry Pi, if it happens to be going off, saving a file somewhere, or doing something else, yeah, it may not get the timing correct because it may have switched off to another task. So you're going to get some variation there. I've got it rounded off to 1 decimal place, so it's 1/10 of an inch. And it's pretty good. There are a few times where you see little ripples in it, which I don't know why they're there. I suspect based on the size, they may be correlated to the wavelength of the ultrasonic pulse. Because you're getting a lot of near field, I don't know if there's any physicists here, but you're getting some near field effects. It's bouncing off the sides, it's off the bottom, it bounces back off the top. It's bouncing off the pump, it's bouncing off the pipe. So you've got a whole bunch of stuff going on in there, so the precision of that measurement is not guaranteed. But if you just do it in an open space, yeah, it's actually pretty good. As long as you can measure that pulse width accurately.
I think there was a question
Over there?
In the modification you made, whether you were sharing with anybody else?
Sure, yeah, if anybody wants it. I don't say that it's good, but basically what I did was the chart change, I split it into the 2 halves because it was long and narrow, which is not necessarily a good fit on a screen, so I blocked it up to make it a little bit squarer. And then I wrote, using his original sensor module, I wrote a modified one to fit the characteristics of my sensor. And the thing is that the sensors come in different forms. There's the 3-pin, there's the 4-pin, there's 2 transducers, single transducer. There's ones that have just the pulse width. There's ones that actually have a serial interface. So I went cheap. You know, it's $5, $7. If you want to pay 25 bucks or more, you can get one with a serial interface. There's also ones that are waterproof, so you could, have it in the water stream if you really wanted to. So there are various ones that you might have to change some of the configuration variables to match that particular sensor. But at least this way, his original has the 4-pin one, mine is the 3-pin one. That covers pretty much all of them.
Kind of a slightly over the top, but in terms of accuracy, if you kind of took a piece of 4-inch PVC pipe and you kind of aiming tubes down.
I tried that. It didn't really help very much because then if you look at the spec sheets for the ultrasonic sensor, they have a cone width, and all of a sudden they start bouncing off the sides. So where they might have had a cone width that they didn't hit the sides much, they may only get that on a reflection. When you've got a pipe, now you're definitely in the cone of that signal. So I didn't find that it really worked all that well. I thought the exact same thing, that it might get rid of all the other bounces, but it didn't really.
I'm just curious, like, how long it took you to kind of work from start to finish, I guess.
Well, the software was easy. Because it was already written for me. The difficult part was getting 2 things. One was cleaning the data, because I had to basically allow for that rapid transition downward and a rapid transition up. The particular plot that I showed doesn't show it, but when the pump goes, it takes it right down to the bottom. But there's a 10-foot pipe going up. As soon as the pump stops, all that water rushes back. So if you take a measurement, the measurement happens to be when it's empty, the next measurement is going to be a couple inches higher. So I had to allow for those, otherwise it would say, no, that's an error. So those all had to be allowed for, and then you sometimes get spikes in the middle. That varies a lot. I think a lot of those are caused by ripples. I haven't left the thing open and tried to correlate it when we're getting droplets and getting ripples on it compared to when you're not. The other thing was the placement. You noticed it was near the front and it was actually off to the right. So I don't know how many different placements I tried that just to try and get one that was clean enough that it wasn't catching the edge of the pump, because there's a float going on the pump that's going up and down to trigger the pump. So it's not a steady state situation. You've got a float moving, you've got water coming up, you've got ripples. So finding the sweet spot was probably the most time consuming, because I'd have to put it in, let it run for a while to see how good it was, and then move it a little bit and say, well, is that better or worse? And it was kind of a pain. But
did you have some experience with the Raspberry Pi? Or did you
Oh, I played with it, yeah. Like I got that one back in 2012 and I had played with it, and this was getting on towards the 2015 timeframe by the time I got around to it. And I've got, I don't know, 3 or 4 of them now, just to play with, doing various things. So.
Awesome. Anybody else? Or?
Have you gotten any false positives?
Sorry?
Have you gotten any false positives?
Not once I found that sweet spot, no. Before that, yeah, I got lots of them. A lot of them were because I would get a spike near the top when it was near the alarm condition. All of a sudden, it would read one above the alarm condition. So that's why I put in the cutoffs for spikes to make sure that I wasn't getting those, and then moving it around to various locations. I actually, I don't know if you noticed, there's actually some foam rubber on the inside of the lid to try and absorb some of the reflections. So once I got there, I've only had the one alarm, and it was a real one. And that's been, I think since 2015. I'd have to look for sure to see. So worked out fairly well.
Great job.
Okay.
Okay, I'm gonna come out here actually. So I don't need my slides for the first bit. Hi everyone, I'm Stephen Luoma. That is my name. I'm gonna be talking about making a basic neural network. So this is something that's gonna be really simple. If you've already done some machine learning, this might be quite boring because it's gonna be very basic, try to help people. So what am I gonna do today? I'm gonna tell you who I am. I told you my name, but not much else about me. I'm gonna talk about why I'm bothering to have this presentation. Have people take the time to see it. I'm gonna talk about what neural networks are actually good for, because they're good for some things and maybe not good for others. I'm gonna show you what it looks like on a whiteboard, classic. I'm gonna talk about what it might look like in code, so that's where you get the 6 lines comment from. I'm gonna talk about some tuning options. This is when you're trying to improve it a little bit, just to cover maybe a little more depth for some folks. I'm going to talk about what else you can do, so making sure it's good and things like that. And then I'm going to point to some resources. So this is kind of going to explain where you can go from here after learning this, if you want to. So who am I? I'm happy there, probably because I'm thinking about dogs or something. So I'm Stephen. I'm a first-year student at NAIT. I have a degree in statistics from the University of Alberta. And at NAIT, I'm doing computer software development. So I'm taking that program there. I'm also a supplemental learning leader at LATE for databases. So I help people if they want extra content for their intro to database course. And dogs and video games are big parts of what makes me happy. So if I'm not doing schoolwork or code or trying to learn something new, probably hanging out with one of these things. Maybe both at the same time if I'm lucky. So why have this presentation? Well, when I was first starting, I was very, very frustrated with how the information on the internet was always very confusing I was new, I didn't have any formal training, and I was trying to figure out how to actually make one of these things. So what ended up really saving me was blog content, I know, right? And YouTube, you know, the typical things you might go to. So some of the good resources were 3 Blue, 1 Brown, Jabrils, Giant Neural Network. I mean, that's a pretty obvious name, right? And a website called Machine Learning Mastery, which is actually where the content for this was inspired from, because I found it very good for when you were basically having no knowledge, which was my goal. I wanted to make it more accessible. That's kind of the goal. So I just want to go over basic understanding and why you might like to do this. I do want to make 2 notes. One is I'm not associated with anything I'm talking to today, so I don't run any or get any money from any of those YouTube channels. I don't do anything for the Machine Learning Mastery website. I don't do any of that stuff. They're just resources that I liked. And I also want to note that I don't actually have formal education in this topic. So I do have a statistics degree, and I do go to school for computer software, but that doesn't mean that anyone in any of those systems ever talked to me about machine learning. So most of my experience is from papers and blogs, tutorials, all sorts of things, mixing together to try and get something functional, something of an understanding. So let's talk about what they're good for. They're very good for classification problems. So these are problems where you have a bunch of inputs and you want to figure out what you're actually looking at. The classic example might be handwritten numbers. So handwritten numbers, you might want a computer to identify them. That would be a classification problem, you know, digits 0 through 9. They're very good for challenging media formats. So typically that means video, images, and audio, where it's really hard to kind of do easy math with those. The neural networks tend to excel there, and unfortunately a little cut off by the board. Sometimes they can also be used for classical problems and do a little bit of a better job. So the problem we're going to be talking about today is a regression problem, or at least it's going to be based on a regression problem that is from the Machine Learning Mastery website. So we're going to talk about that. So what does this thing even look like? Well, we're going to draw it on here. So let's go through it. Okay. Code. So let's look. We've got some imports. I'm using something called the Keras package. And the reason I'm using this is it does neural networks extremely easy in 6 lines of code. So this is a whole neural network. So that's really, really easy. I don't have to go program how it's handling everything. I don't have to go make my own optimizer. I don't have to define the loss function. My life is simplified by this. So let's draw this. Let's draw it. So these I don't want to draw because importing, I don't even know what I'd draw, just some books or something. But let's just draw the model. So model equals sequential. So all this is essentially saying is my model is going to start on the left, and it's going to move to the right, and if it's back propagating, it's going to go back left. That's all that says. So you can imagine sequential is my whiteboard here. That's what this line's saying. Then I have my first layer I'm going to add in. So I'm going to add a hidden layer. Don't worry, we're going to go slow through this. It's densely connected. It's going to have 5 nodes because I didn't want to draw more. It actually has 13 in the tutorial. I don't want to draw 13. Oh, God. What is that? 169 lines I have to draw? Nope. An activation of ReLU. We'll talk about activation. Input dimensions 5, so I'll be drawing that. And kernel initializer, and I have a comment about this thing. So let's draw it. So the first part I'm going to draw is it's a dense layer. Okay, fine. I don't know what that means yet, but I'm going to draw 5 nodes. Oh, I drew it too big. Let's make this more reasonable for how much space we have here, huh? Okay, so 1, 2, 3, 4, 5. Okay, 5. Awesome. I'm doing great. Okay, I got to do activation functions at some point. I don't want to draw those. It's whether it lights up or not. I don't know. Do I color it in? I don't want to do that. And then I've got my input dimensions of 5. So I'm going to draw my 5 inputs. So I've got 1, 2, 3, 4, 5. So I got my 5 inputs. I'm doing great. I've got through like this whole thing almost. except for I mentioned dense. Now I got to show you what dense means. So dense means that they are densely connected. That means every node is connected to every node in the next layer. So I don't know, you guys can go on your phone while I draw 25 lines. If you're doing it on paper and following along, you feel free to do this too. This is densely connected. This is why I chose 5 over 13, which is what was originally here. Oh my gosh. Can you imagine if I stood in front of you guys for that long just doing this as you all want to go home, begging me to stop? Like, that's enough lines, I get it. You're dreaming about it later. Oh gosh. I'm almost done, I promise. I've been counting. That's 21, 22, 24, 25. Oh, so beautiful. Isn't it wonderful? Look at that.
For the activation function, since it's ReLU, you could do like.
And I do it inside the node.
Yeah, inside the node. You would have to be, That's what it is.
Okay, let's do it. Don't worry, I'll explain what this is later. Apparently Eddie already knows. Okay, so then there's this line. I just separated these because it looks a little cluttered when you do it, but you don't have to make these in 2 lines. You could make this 4 lines even. But I just wanted to make it really clear that now I'm going to add this to that sequential model. I've already drawn it, so you can imagine I've added it. Then we're going to do our output layer. So this is kind of what I'm looking for, and it's just going to be 1 because we're doing a regression problem. So we're just looking for 1 output. We're looking for its guess at the thing we're interested in. So we just want 1 output. So I'm going to draw 1. Oh, okay. It activates linearly. So this time, what do I do, Eddie? There you go. That's it. Straight line. Ah, so nice. Okay. What else? Oh, densely connected again. This time it's only 5 though. Ah, 1, 2, 3, 4, 5. Nice. Oh, how am I not done? Okay, so so let's talk about kernel initializer. What's that guy? Okay, when I was first starting, nowhere would tell me this thing. I was so grumpy. No one would tell me this thing. How do I choose my starting weights? Those lines? How do I choose them? What is this when it starts? I know what it's doing. It's going to go through and fix them. Where do I start? It turns out randomly. And everyone just thought it was implied and that everyone just understood it and that so I should understand it, but I didn't know. I didn't know how they would start. So this one says I'm going to start randomly, and it's going to start on a normal distribution. So from, let's say standard normal distribution, so from -3 to 3. So it's just going to pick a number in there as the starting weight. That's how it's deciding its initial weight, at least in this model. That's how this guy works. So I did that for both of these. So all these weights are numbers like -3, 3, there's a lot, I'm not going to do all of them, 1, 0.1, and most of them should sort of be closer to 0 because of how a standard normal looks. Yes, Eddie?
I realize we have not discussed what a weight is.
That's true. Would you like me to?
Yes, please.
Okay. A weight is essentially something that's going to be applied to the value that's being sent to the next layer, and it's going to adjust it according to the weight. And these are the things that kind of get updated through the model. For example, with the -3, if I send like a value of 1, and then the -3 gets applied to it, then it's -3 when it goes into the next guy, and then whatever else happens on the next one, etc.
So clarify. That
Yes.
kernel initialization, what you're saying is, before we start the machine learning,
Yeah.
we just make it random.
Yeah.
All the weights are random.
Yeah.
Okay.
Let's start random. We don't know where it's going to be good. Let's just start random. So then I add this output layer. I've done that already. I added my output layer. And then I'm going to compile it. So this is kind of the last little bit here. When I compile it, I just kind of got to tell it what it's supposed to care about. So I'm telling it that it needs to care about mean squared error because we're doing a regression problem here. So that's usually typically what you'll do is your loss function. So I'm telling it to care about mean squared error, try to make that as small as possible. And I'm telling it to use the atom optimizer. There are a lot of optimizers you can use. Really popular ones include stochastic gradient descent. You've probably heard that term before. And the other really popular one is atom. With stochastic gradient descent, you'll often add something called Nesterov momentum. That will come up later when I show one of the modifications you can make. So let's grab my clicker since I left it over here. Yes. So what else can I add? I made this lovely guy. I've got my input layer, my layer. Oh, I should explain what relu is. Eddie brought it up. I should explain what relu is. Relu is an activation function. Activation function is a fancy term for when am I going to light this up and say it's active. So when I give it a bunch of inputs, is this one going to light up and say it's active when it goes to try and predict this? Relu, what it'll do is if it's something negative or 0, so negative to 0, any range in there, it won't activate. And then if it's positive, it will activate with whatever value you've sent it. So exactly the value you sent it, kind of like our linear guy here. And then the linear one, just whatever you send it, that's what it's got. It doesn't do any changes to it. It's how you would expect it to be. So let's talk about one of the tunings we can do. We can, oh, it's kind of cut off, but we can add a dropout layer. So what is a dropout layer? Well, I gotta bring in more stuff. The difference between the last slide and this slide is these two lines where I bring in some more libraries I need. I bring in 2 optimizer options, which I will explain, don't worry. And then I'm gonna bring in my dropout layer. So the code before probably just looked like that without the dropout. Yeah, that's like 7, right? Yeah, that makes sense. So without the dropout before is what we had. So now we've got this dropout layer. So what's a dropout layer? A dropout layer essentially gives a chance for a node to not activate. So in this case, I've set it to 0.2. That's equivalent to 20%. So essentially it would give this a chance, a 20% chance to just not glow, even though it was supposed to not light up. There is a technical way of saying this, and I believe I wrote it. It reduces codependency between neurons. Great. That's not very useful if you don't know what any of that stuff is, right? But the more human way of saying it is it helps reduce overfitting. So what is overfitting? Overfitting is where you go to make your model and train it, and it's only really good with what you trained it with, and it sucks with new data. Real bad. It's not even close. It's not trying. And that can happen when you train it a lot, or if there's just a lot of noise. Sometimes it'll think like noise is part of the model and just assume that it's doing it right, but really it's making a lot of mistakes. So one of the things you can do is add this dropout. But when you add a dropout layer, you want to add a higher learning rate. And the reason is because now you've got stuff turning off and on semi-randomly, like 20% chance to turn off. So you want to account for that by making the learning rate higher. You can imagine learning rate's kind of like the speed you're driving, and then there's bumps in the road, and you don't want to get stuck in the bumps, and the dropout might make it so you get stuck in those bumps. So you want to like zip over the bumps. So you can imagine there's like potholes, and you want to not go into the, oh, that's a terrible example. You don't want to speed over potholes, do you? Okay, don't do that. Don't speed over potholes. I do not condone that. Don't do that. But essentially, it lets you get over these little holes, these these local minima that get you stuck on not the optimal result, because your goal is to get to something close to optimal. You want to try to get to the global minimum, but sometimes it's really hard to tell what you're doing. Another option you can add is something called batch normalization. That's some statsy stuff. Okay, let's do the fancy talk first, because it's right here. It limits covariate shifts and it reduces high order effects. Okay, that's nice. So it's just a fancy way of saying it helps limit the change in distribution of the input values. So that means if you have some data that's not really normal, you got some stuff that's weighted too highly than it should be, it'll kind of put everything together and kind of keep it more like what you'd expect. Normalization comes up a lot when you're talking about standardization. So you're trying to make everything really, really similar when you're sending it in, so that nothing gets exaggerated. And then the reducing high order effects, essentially, earlier layers. So in our example, we just kind of have like one hidden layer, but you can imagine you can add like 50 of them if you want. You can add tons. And earlier layers can affect later layers. So what batch normalization does is it helps with those issues. And it typically only helps when your network's deep. If you were to add it to this, I don't know how helpful it would be. But if you have quite a deep network, it can help a lot with that problem. I do want to make a big note. Don't use this guy, batch normalization. You notice he's in the same location as the dropout. Don't use him and dropout at the same time. And see, Eddie's laughing because he's done it. So, and he knows, he found out why. So when you're normalizing something, you're kind of taking all these values and weighting them. When you randomly turn some of them off, and then you go to do that, you end up ruining everything by not weighting them correctly, because some of them got randomly turned off. So you end up with like horrible problems where it just isn't learning and you don't know why. So definitely keep them separate if you're going to be using those. So let's talk about what can I do next. How do I check if this is even good? Okay, I'm going to talk about 3 things that are outside the scope, but they're little teasers. So if you go to any of the resources I send you to, you can actually figure out how to do them. So the first little tease I'm going to make is something called K-folds cross-validation. So that means that you're going to take all your data, you're going to break it into however many folds you want, hence K-folds, and then you're going to take one of them and leave it out. You're going to train with what's left, and then you're going to see how well it guesses the one it left out. And you're going to do it for each fold. And that lets you kind of see how well it would do with new data. That's kind of the idea of that one. There's also checking overfitting by graphing it, where you will do something called putting the number of epochs. So that's how many times you're kind of repeating the training process. You're going to put that on your x-axis, and then you're going to see what the error is like for the group left out and then the training group. And you're going to see whether or not there's problems where it's not guessing as effectively as you used to think. And then the last thing you can do if you're really cool, I couldn't do this. My computer tried to set on fire when I tried to do it. It's called grid searching. So this is kind of a brute force way of checking a ton of models in a short period of time. Hopefully it's short. My computer was on fire before it was done. But you try to find the best model by just checking a ton of them. And that's basically the idea of it. If you got a really good computer, I'm sure you can have fun with that, where you don't have to do any work. You're like, I don't have to know how to tune it. I don't have to fix it. I can just check all of them. And it'll just tell me which one's the best one. So I did mention that you could go somewhere to do more of this, because I did show the model, and I did explain kind of how to make the model, but that doesn't really run anything. You just kind of got a model, and you're not doing anything with it. So where can you go to learn the rest? Well, this one's based on a tutorial from Machine Learning Mastery. There's a bunch of terms and very high-level language content in here that can kind of explain what's happening with the neural network that I couldn't get around to just because of time. Particularly 3 blue, 1 brown. Fantastic first place to start. Same with Giant Neural Network. They have basically the easiest tutorial I've ever seen. It's this guy, but with 2 inputs and an output and nothing else. So it's like really, really basics if you really want to start from the bottom. Jabril's does kind of variety content, so there's lots of machine learning little projects if you want to be like, I kind of want to do something with it instead, and that's how I'll learn best. So you can get some stuff there. But this one comes from Machine Learning Mastery, and if anyone in here has done everything on that website, I will wonder what your age is, because holy crud, there is a lot of stuff on that website. Specifically, the one we did today, the one that you can continue on if you want to use what we did today, except with the 13 inputs, is named Regression Tutorial with the Keras Deep Learning Library in Python. That's its name. It'll be in the notes of the slides, and Dan said I could have some way to provide that to the people of the group. They'd be able to see it. Do we have any questions? Criticisms, concerns? Eddie, did I ruin everything? Did I do it? It was all right?
I have some hot tips to share.
Oh, goodness.
So remember when he was talking about the what's it called? Optimizer. That's the thing that tweaks the knobs. That's the thing that touches the knobs and stuff. Atom is empirically good. SGG is just kind of the classic, but you'll find references all over the net about RMS prop.
Yes.
Okay, this was like posted on a slide by Jeffrey Hinton. Jeffrey Hinton is like one of the gods of deep learning. Anyway, he posted on the slide kind of as a throwaway in one of his machine learning courses.
Okay.
But then somebody decided, hey, yeah, why don't we use that everywhere? Even though it was just kind of like part. Like it wasn't even
Which optimizer are you talking about?
RMS prop.
Oh, yes, yes.
It's garbage. Don't use it. It's a
I
waste of
have,
time.
yes, I've actually never used that one on purpose.
Use Atom instead if you.
Atom is good, yes. The two most popular I found when I was doing research, this wasn't blog research, this was the actual research paper research, was stochastic gradient descent with Nesterov momentum, and the Atom optimizer tended to do the best. So those are typically the ones I start with if I'm checking something. There are other ones as well. Yes?
And I think just a bit more context, I think Adam is really good because it actually adjusts the learning rate as it
Yes, 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 it has that.
starts with one learning rate and then as it starts to optimize it, gradually decreases the learning rate because you don't just want to jump over whatever minimum or maximum you're trying to get to.
Absolutely, and they've got the, there's a lot of visualizations on YouTube of Atom working where you can see it, at least in like planes, you can kind of see how it works. You're absolutely right. There's lots of good stuff with that. Yes, sir.
Find the model there.
Yes.
In the middle row of circles.
My little hidden layer here, yeah.
You're going to be tossing anything negative, basically, right?
I can toss it something negative, but it'll send 0 out. Because
You're not
any,
tossing it, you're actually making it 0.
yeah, it'll make anything 0. That's what the ReLU does. I'll draw it a little bigger, but on like a graph. So let's look at it. So, Y.
It's rectified linear unit.
Yes, that is the full name. I didn't want to do the big technical term. I just wanted to cover it. So it kind of makes everything 0, and then when it's positive, it goes up.
So it takes those numbers coming in,
Yeah,
does that, applies that to them,
yeah.
and then what happens, what then happens? It's getting 5 different inputs.
Yes, this guy, this node here.
Yes.
Mm-hmm.
So it's getting 5 inputs.
That all have their own. They all have their own weights.
Their own weights and
Yeah.
numbers. What does it actually do with it? It then sums the result, or?
First it
Eddie wants to.
sums up all of the inputs.
Yeah.
Then passes it through the activation function. In this case, it's
ReLU, this guy.
So that's applied after, it's not applied to all, each of the five.
No, it's after it gets everything. And then once it gets here, this problem, I forgot to mention it, but this is a supervised problem. So in our case, we'd have like a thing we're expecting it to get, and then we compare what its guess was with it, and then we tell it, you did pretty good, or you did terribly, or what have you, and then we'd go back and adjust the weights.
That's just the chain rule after that.
Yeah, if you the 3 blue 1 brown actually does chain rule in the very last video where they show the gradients. If you want to do the big math part where you want to really understand what's happening here, you can absolutely. Any other comments, questions?
One last comment.
Sure.
And the reason why we do the k-fold cross-validation
Mm-hmm.
is, say you have so much data and you don't want to split into training set, validation set, and test set.
Mm-hmm.
Then you
Yes.
use the cross-validation to kind of generate an artificial validation set without it.
Yeah, you can imagine it kind of helps you with that. Yeah. Yep. Absolutely correct. Oh.
What sort of problem are you trying to solve? What kind of data would you feed it?
The one in, well, so this is a regression problem, so it can be any regression problem since it's just kind of imaginary. The one in the tutorial I spoke of is doing some house pricing for some Boston house prices. It takes 13 inputs. I don't remember what they all are, I'm sorry, but it takes 13 inputs. You have a hidden layer, and it's going to try and guess the price of the house. So that's what the actual tutorial that this is based on is trying to do. Yes, Eddie.
All the inputs are then just real value inputs, or they
Yeah.
do you pre-process them in any way, or is it just
You can. I'm not sure if the data used for this tutorial is pre-processed. I can't recall.
'cause, like,
But
do you just put in square footage, like
right, exactly. Like what are you putting in? Typically, you wouldn't do that, right? You would do something on the way in. I'm not sure if this tutorial does, because I know this tutorial is trying to keep it simple so people can approach this. But yes, typically you'd want to clean on the way in or do something with your data on the way in so that it's not doing strange things. Yes. Anything else?
I can save a life.
Oh?
Okay, if you're using, so Keras is really nice because it's really easy.
Oh, you use Keras too?
Oh yeah.
Oh.
Yeah, it's so good.
I love it.
Well,
It has a TensorFlow backend. Oh.
anyway, it's really simple to set up a neural network, but say you're doing, I don't know, time series stuff or character-based stuff. So they tell you, oh, neural networks for time-based, time series, character stuff, like language processing. Use a recurrent neural network. Cool. And then somebody else tells you, hey, you know what a good idea is? Use dropout. Drop out some of the things on your node. Don't go into Keras and do what he did, where it's like my layer, my awesome RNN layer, and then dropout, because that's not actually what you want.
Yes. Especially not with RNN. Yes.
Especially not with RNN.
Yeah.
What you want, in Keras, there's a way to set, say, in the specification of the RNN, within it, hey, could you drop out some of the nodes inside?
Yes, I didn't go into RNN. I didn't want to, but
Yeah.
it has a setting inside of it. Yeah, LSTM also has that, I believe. Yeah, LSTM. Yeah, any of the ones that are kind of in that classification have that option, yes. But again, I was trying to keep this very high level just to be introductory. That was my goal because that's kind of what I wanted when I was first starting. I was frustrated, so that was kind of what I wanted to do. And resources, I wanted resources. Really bad. Yeah, that's it. That's all I got.
Thank you so much.
Thank you very much.